So the first topic of today is Mealy and more models. Before we begin or get into the topic of the Mealy and the more models, we need to understand as to what these characterization of models are. So for that, we need to understand something called as an FSM, that is the finite state machine. So a finite state machine or FSM is a computational model that can be used to simulate sequential logic, or in other words, to represent and control the execution flow. So here is one block diagram or one state diagram which shows a finite state machine. And these finite state machines can be used to model problems in many fields, including mathematics, artificial intelligence, games, etc. Now the key points that you need to remember here are, we will be having a fixed set of states that the machine can be in. So here you can see in this particular state diagram, the two states are locked and unlocked. This is basically an FSM which describes one of the examples where you can see in foreign countries where you have the gate opening and closing in your railway stations when you want to enter or when you want to leave the station. When you consider, say you are in the initial state and the gate will be locked, so you will have to place a coin. So when you place a coin, the gate will be unlocked. So when you are in the unlocked state, even if you place a coin in it, nothing will happen. Whereas once you have placed the coin and it is unlocked and you push the gate, it will be locked. Next, when you try to push it, it will be in the locked state itself. It is only when you put a coin again, the gate will be unlocked. So this is one simple example that you find in the railway stations basically in foreign countries, where you get to see the entry gates. So that is called as turntile gates, which tend to open and close for a passenger. So the main important thing that you need to remember in the finite state machine is that you will have a fixed set of states that the machine can be in. So if this is a finite state machine, the two states that are present here is locked and unlocked, and the machine can be in one state at a time. So you can see I have explained that either you will be in the locked state or you will be in the unlocked state. The sequence of inputs is sent to the machine. The sequence of inputs in the sense, here I can push or I can place the coin. So depending on that, I will switch from lock to unlock or unlock to locked. So every state will have a set of transitions, and these things, that is coin push operation, is called as a transition, and every transition is associated with an input and pointing to a state. So that is why you can see that we have pointed it using an arrow mark. Now, to understand what is the relationship between the finite state machine and the Mealy and the more models that we are going to study, the finite state machines are an important category of sequential circuits because they are frequently used in designing digital systems. So generally there are two types. One is the Mealy machine and one is the Moore machine. The Mealy machine is the one in which the output is a function of the present input conditions and the present state of the circuit. Whereas Moore machine is the one in which output is strictly a function of the present state of the circuit. So if from what we have learned, we can see that a synchronous sequential circuit is also called as a finite state machine. And these machines, that is the Mealy machine and the Moore machine, are named after their founders, that is GH Mealy, and More machine is named after EF More. Now, other than this, where do we use these finite state machines? So, from your daily used electronic machines to very complex digital systems, we use the FSMs, that is finite state machines. So another example, if I have to give you, in a station where we make use of the vending machine which will dispatch a ticket using a simple FSM. Now the one which I explained in the previous slide, here it was meant for opening and closing the gate in the railway station. The next example could be using a vending machine which will dispatch the ticket when you place a coin. Then we can also use in complex digital systems where the controlling part is most of the times implemented by using FSMs. Moreover, most of the digital systems either use the More or the Mealy machine, but both the machines, that is the More machine and the Mealy machine, can also be implemented together. So that we will see further in the tutorial, how we can implement Mealy machine separately, More machine separately, and then how we can combine them together. So in the initial days of the digital system design, when HDL languages were not discovered, these Mealy or the More machine was realized using K-map realization or the K-map optimization technique. But the K-map optimization technique provides only an optimized solution, but it is very rigorous and the process is very lengthy. So what we do is we try to go for an easy solution to the design of the FSM, that is by saving the design time. So here in this particular FSM tutorial that I'm going to explain, we are not going to focus more on the design part. We will be focusing only on the main difference between the Mealy machine and the More machine, and how we can design the state diagrams for the Mealy machine and for the More machine. We will not be looking into the HDL programming part. Now, coming to the Mealy and the More models, I have already mentioned that FSMs are an important category of sequential circuits. So they are used frequently in designing digital systems. So sequential model will include combinational and the memory subunits. These memory subunits will consist of the flip-flops, which will update the circuit status information, and the input logic and the output logic will consist of combinational circuits which are used to generate the next state and translate the input and the flip-flop output information. The input logic will provide or produce the excitation inputs to the flip-flops, and the output logic will convert input and flip-flop data to satisfy the output variable requirements. So let us understand that in a much better way. So here is a more sequential circuit model wherein you can see that we have the input variables that are given to the input logic. This is supposed to be an input logic, okay? It's written as input, it's input logic. Then we have the memory and the output logic. So input variables are provided to the input logic, and then you have the memory, then you will have the output logic. If you observe, the output of the memory is also given as an input to the input logic. So these will generate the state variables, and for the memory we need to provide the clock. If you are to compare the More sequential circuit model with the Mealy sequential circuit model, you will observe that this is exactly the same, but the difference lies in the fact that in the More model, the relationship between the input variables and the output logic. Here it is indicated by a dotted line. The dotted line basically means that there is no connection. So the main difference between the Moore sequential model and the Mealy sequential model is that there is no relationship between the input variables and the output logic in the Moore sequential model. So what I can say is that a Mealy sequential circuit will differ from a Moore circuit in the variables used to generate the output function. And in the Mealy model, the external input variables and the state variables are applied to the output logic to generate the output variables. Moreover, in the Moore model, the output is dependent on the state variables. As you can see, there is only this particular connection which will generate the output logic and then the output variables. So in the Moore model, the output is dependent only on the state variables. Now, to conclude with the difference between the Mealy and the Moore model. So from what we have understood in the block diagram, we can say that Mealy machine will have the output which will depend upon the present state and the present input. Moore machine, the output will depend only on the present state. And Mealy machine has fewer states than the Moore machine, whereas the Moore machine has more states than the Mealy machine. The output will change only at the clock edges in the Mealy machine, whereas in the Moore model, the input change will cause the change in the output. And another major difference would be that the Mealy models will react faster to the inputs, whereas the Moore model circuits will have more delay in comparison to the Mealy machine. So with this, we will be completing the basic difference between the Mealy and the Moore model in terms of the block diagram and also understanding what is a finite state machine.